In this unit, we're going to learn about the exponential function. First, let's review some of the properties of exponents. Product rule, a to the m times a to the n is a to the m plus n. For example, 2 to the power of 3 times 2 to the power of 5 is 2 to the power of 3 plus 5. So that's 2 to the power of 8. A to the power of m divided by a to the power of n. For dividing, we subtract the exponent. So 2 to the power of 7 divided by 2 to the power of 3, 2 to the power of 7 minus 3. So that's 2 to the power of 4. So as long as the same base, you can perform this operation. Power over power rule. So a to the power of m to the power of n is the same thing as a to the power of mn. So 2 to the power of 3 to the power of 4, the same thing as 2 to the power of 3 times 4, which is 2 to the power of 12. AB, the whole thing to the power of m, the same as a to the power of m, b to the power of m. For example, 2 times 3, the whole thing raised to the power of 4 is the same thing as the power on each one. So 2 to the power of 4 times 3 to the power of 4. Similarly, for 2 or 3 to the power of 4 is in the powers applied to each one. 2 to the power of 4 over 3 to the power of 4. Zero exponent rule, any number that's non-zero raised to the power of 0 is 1. So 2 to the power of 0 is 1. Negative exponent, a to the negative m is 1 over a to the m. 2 to the power of negative 3 is 1 over 2 to the power of 3. A to the power of m over n is the nth root of a to the power of m. So example, 2 to the 3 of 2 to the power of 3/4 is the 4th root of 2 cubed. Exponential function is defined as f of x equals a to the power of x, where a is a positive number and a cannot be 1. A is called a base. For example, this is a function base 2 function. F of x is 2 to the power of x. So f of negative 1 would be 2 to the power of negative 1, which is 1/2. F of 3 would be 2 to the power of 3, which is 8. And f of 5/2 would be 2 to the power of 5/2. F of 4.92 would be 2 4.92. So here's the graph of f of x is 2 to the power of x. At x is 0, f of x is 1, 2 to the power of 0 is 1. At x equal 1, 2 to the power of 1 is 2. At x equal 2, 2 to the power of 2 is 4. So as the number at each unit, it increases by doubling the value. 1 to 2, 4, 8, 16, etc. And also in the negative direction, negative 1, 2 to the power of negative 1 is 1/2. 2 to the power of negative 2 is 1 over 2 to the power of 2, which is 1 over 4. Negative 3, 2 to the power of negative 3 is 1 over 2 to the power of 3 is 1/8. So still halves if we go leftward. And as x to infinity, it's gonna be really small. So, but it never touches it never gets to 0. So the x-axis is the horizontal asymptote. So for function f of x, a to the power of x, if a is greater than 1, then the function is increasing. For example, f of x to x, it increases a greater than 1, and if a is between 0 and 1, then the function is decreasing. So for example, if x is 1/2 raised to the power of x, the function decreases. So this figure compares different values of bases. So 2 to the power of x, 2 to the power of x, 10 to the power of x. So 10 to the power of x increases faster than 3 of x, because the one is multiplied by 10 every unit, 10, 100, 1,000, etc. And similarly with the 1/10 x, it decreases faster as well than the 1/3 and the 1/2. Also, the function is either increasing or decreasing. So therefore, it is a one-on-one function. because it would always pass the horizontal line test. It would touch only one point. And since it's one-of-one function, we can use this property. So to solve this equation, 2 to the power of x is 8. So which is the same as 2 to the power of x is 2 to the power of 3. Since it's one-of-one function, we can conclude that x equal to 3. So now we have 2 to the power of x equals 27. 3 to the power of x is 3 to the power of 3. So we can, since they are the same base, we can conclude x, the exponents be the same. So x 1/3 equals 4. We can cubic on both sides so that we can get rid of the denominator. So now we can x is 4 cubed, which is 64. In this case, x to the power 2/3 is 4. We can raise to the cube again. In this case, 3 cancel, we still have x squared equals 64. And then we can do x is plus or minus square root of 64, which is plus or minus 8. 5 over half, 5 over 2 raised to the power of x is equal over 25. So the goal is to have the same base, right? 5 half and 5 half. This is kind of an inverse, so we can use the property. So the inverse would be, if we inverse it, just negative the exponent. So 4 over 25 is the same thing as 25 over 4 to the negative 1. And 25 is 5 square and 4 is 2 square. And then we can use 5 square. Since this is the powers negative ones of the whole thing, we can apply the negative 1 onto each one. So this 5 to the negative 2 and 2 to the negative 2. Then we can combine this as the same exponent. So 5 over 2 to the power of negative 2. And finally, we can equate the exponents since we have the same base. So x equals to negative 2. Or another way is we can change the left side instead. So 5 over 2x, 5 over 2 raised to the power of x is the same thing as 2 over 5 raised to the power of minus x. So 5 over 2 raised to the power of x is the same as 2 over 5 raised to the minus x. And the right side is 4 over 25, that's 2 over 5 squared. And now we have 2 over 5 raised to the power of minus x is 2 over 5 raised to the power of 2. So same base, we can equate minus x and 2. So x is minus 2. In this case, 2 to the power of 3 minus 2x equals 8. So 8 is 2 to the power of 3. So we can equate the exponents. So 3 minus 2x is 2. And then we can solve for x. So now to be x cubed. 5 to the power of 2 plus 2x equals 25. So 25 is 5 squared. So 5 and 5, we can equate the exponent. 2 plus 2x is 2. And x solve for x. So e is a special number that we will look at in a little bit. But the idea is get to have the same base. So this is e, so we should make this a power of e as well. So e to the power of 2x is the same as e to the power of 2x. E to the power of 2 raised to the x is the same as e to the power of 2x. So now e and e, we can equate the exponents. So for x minus 1 is 2x. And then we solve for x. So square root of 2 raised to the power of x plus 4 equals 4 to the power of x. So 2 square root of 2 is 2 to the power of 1/2. And 4 is 2 squared. So now we can use the property to power of powers. Then we can just multiply 2 to the power of 1/2 x plus 4. And here's the same thing, 2 to the power of 2x. Now it's 2 and 2, we can equate the exponents. Then we can solve for x. So compound interest, use this formula. A equals p times 1 plus r over n raised to the power of tn. So p is the principal amount or the initial amount. R is the interest rate. N is the number of times that it's being compounded per year, and T is the number of years being compounded. So for example, $1,000 deposited in an account paying 4% interest per year, compounded quarterly 4 times per year. And the amount in the account after 10 years with no withdrawals. would be using this formula: AP times 1 plus R over N times T to the N. P, $1,000 starting amount, the principal amount, 1,000. Interest rate 4% is 0.04. It's compounded 4 times per year, so that's 4 and 4. And T is the number of years total. So after 10 years, T is 10. And then so we calculate A to be 1,488.86. So after 10 years, the money goes to this amount. And so the interest earned in this period is that minus 1,000, which is 488. So the number E that we saw earlier, it's about 2.78, etc. And the numbers are obtained by using this formula. So it's similar to the interest rate, right? So it's 1 plus 1 over n to the power of n. N is the number of compounding, right? But if n is compounded continuously, or n approaches infinity, this number A is going to approach this number. And that's how E is obtained. And this page just compared the E with other ways of compounding. You can read up on this, but will not be on the test.